In the last video, we created this combinational structural multiplication, m times q. Now we're gonna design a test bench file for this one. So first we must create a Verilog file and let us save it as Testbench M times Q multi, and save it. So first what we're going to do, we can declare our timescale. So with a resolution of 1 nanosecond. And then we create our module. So it must be the same name, Testbench M times Q multi. And then we need a end module. So first what we must do, we must declare our inputs. So in the test bench file it's reg. So we know we have the first, it was m, and so we can call this as test bench file m, test bench file m, and it is with up to two vectors. So it means that it has a length of 2. And then next it is reg q, and this one it is with the length of 2 bits. So test bench q, and then we have our outputs. So the output that we have, it was p, so the product, and the product it have the length of 5 bits. So, and then we output its wire, and then this is, so the product is 5 bit, and then we can call it test bench p. So we have our multiplication on multiplier and the product. So what we can do next is we need to instantiate this model here that we want to simulate. So the model name is m times q multi, and then we can give it a module name m1. So this is our module, and we know we have our input is m, q, and p. So it is m, and then it's corresponding, it is m, and then the next that we have, it is q. So it's q, test bench q, and then we have p, this product, and test bench p. And then we can close it, this one. So what we want to do next, it is to declare the length of our simulation time. So how long we're gonna simulate it. So let's try to create an initial begin, and then end this. So we have let's come back to it because it depends on how long we want to simulate it. Let's create our combination that we want to test with M, Q. So we want to test all the bits of M, all the bits of Q multiplying together. So first of all, we need to test from 0 to 7 times 0 times 1 times 2 times 3. So that it is 8 times 4 is 32. So the total combination is 32. So let's create always. So that we need to create those waves for 32 combinations. So the first one is, let's start with M, 0. So we need to create those combinations with a square wave. So it is equal to, so it's Testbench M, 0. So this line of code here, it will create a square wave with a period of 20 nanoseconds. So we can just repeat this with the next of period of 40 nanoseconds. So this is going to be the second bit. And then 80 nanoseconds. And this one must be of 160 nanoseconds. So this one, it is Q. And the last one, it is 132 nanoseconds. And this is the last bit of Q, the multiplier. So we know that our simulation end at this square wave. So it is 320 nanoseconds. So we can just say 320, and then we finish the simulation. So the next thing we can do, we can just write our initial begin, the value of when the simulation starts. So initial end. So now we want all the value of the multiplier to be 0, and the same as all the value of Q, the multiplier to be 0. So that is all the value should be 0 at the first initial begin. So when the simulation starts, all the value are 0. So this will be initial. And then the next thing that we want to do is to simulate and print those results in the time script. So what we can do, we can create another initial begin. We can write initial begin. So now here we create an offset. So for the first, we don't want to capture the zeros at the first time, so we can just ignore that. We can just delay our simulation for 5 nanoseconds when we're capturing it. And then we want to print our value each 10 nanoseconds, so we can just display those results. So the first we're going to display is the first M bit. So it's just 1 decimal. And then we can print the second. And then we can print the second bit and the last bit. And then we can print for Y. So this is the first bit and the last bit. And then we can print the model result. So the result of the summation. So we can just write model, or which is the product, by the way. So we can call it model P, or we can call it model M to verify that is this the output of this one, but it's just a display. And this one we can say the product, the value of the product, it's 5 bits. So it's %4, and then we need to write the corresponding so this is the last bit of this. So the last bit, which one is this one? So it is the value of 2. So that means it's the third bit. And then we have the next one, it is 1, the second bit, and the first bit, which is 0. And the same as Q, so we have Testbench Q, the last bit, which is 1, and we have Q, the first bit. And then we need to print our result, which is the product, all of it, which is the 5 bits, this one. So let's close this one, just to rewrite this. And the next thing we need to do is to test our result just for verification. So we can write an if statement. So if the result of Testbench P, the product, if the result of our simulation is not equal to Testbench M, so if the result of M times Q we need to capture this error. So if it's wrong, it should display for example failed for model P product, and then it should print the right result. For example, the right result, it is M times Q. And then we need to give the length of those bits, which is 5. The answer should be 5 bits. So what we need to do here is, because this result here must be printed, must be checked and printed every 10 nanoseconds, so we need to repeat this. So we need to create a for loop, and the for loop for this one in the Verilog is repeat. So we want to repeat this 32 times. So begin, and then we can just end it here. Yeah, so let's try to save it and analyze and synthesize. So remember, we don't put the Testbench file as top level entry, it's only the original file. So let's analyze and synthesize. So now we see that we don't have no errors. So let us simulate this one. Let us launch the model sim. So we can see that we don't have any warnings or errors. So let us compile this. So we need to compile these two files here. Compile. And then we simulate. So we can see all the files have been imported. So let us simulate the Testbench file. And then we can add all the values in the region and change the simulation to nanosecond, and let us simulate it, all of it. So now you can see here all the square wave that we have generated. So you can see the first one here with a period of 20 nanoseconds, and this the square wave of period of 40, and then you can see these two here. One of them is 80 and this one is 160, which is 320 nanoseconds, the last one. So that way we have managed to generate all the combinations. So you can see here, for example, the first one, M, it's 1. So you can see the 0, we don't capture the first 0, but it is 1 times 0 is always 0. So you can see here all the first bit is 0, so we have 0 times 1 up to 7 is always 0, and then the next square wave, it is 1, so we tested from 0 to 7, so you can see it's 0, 1 up to 7, because 1 times 1, 2, 3 is only the same number, so we have up to 7. And third one of y, it is 2, so it is 2 times 0 times 1 times 2 times 3. So you can see 2, 4, 6 until 14, until 2 times 7 is 14. And then you can see until the last bit here, which all of them are 1. So you have 7 times 3 is 21. And then there's no fail model, so this simulation work fine. So our design that we have designed here, it work perfect for 3 to 2 bits multiplication. So this one was for this video. In the next video we're gonna talk about the next task.